Take a look at this problem. Again, the goal is to interpret the slope and determine if the y-intercept has a meaningful interpretation. So here we have some data about the weight in pounds of 12 random women, and the y is the number of calories burned in 24 hours, and we want to interpret the slope. So here in blue I wrote the least squares regression line. So I'm going to write a little larger here. Y hat is equal to 10.898x plus 201.16. So for part A of the problem, we want to interpret the slope. So I'm going to put that over 1, like I did in the previous example. And slope is change in y over change in x. I wrote that down here in green that I'm highlighting. So I'm going to add the labels. The y is the calories burned in 24 hours. And the x goes in the denominator, that is the weight in pounds. So then we want to write that as a sentence. So we're going to start off with on average. So that's because we're using a least squares regression line, which is a prediction. And then for every additional 1 pound increase in a woman's weight, the number of calories increases or burned increases by about 10.898. So the components there is you always want the on average, I'm underlining that. You always want for every additional, I'm underlining that in blue. Then after that you put the x context, so in green we have the x context. And I think I put the line a little bit longer, so I'm going to stop it after the weight. And then the last part, and I'm going to underline that in gray, is related to the y value. So that's, I'm underlining in gray. So there are 4 components when you interpret the slope. The red piece, the blue piece, what I underlined in green, and what I underlined in gray. Second part of this problem is, does the y-intercept have a meaningful interpretation? So again, that means x is 0. So if x is 0, y hat is 10.898 times 0 plus 201.16, which means it's equal to 201.16. So does it make sense if someone weighs, so they weighed 0 pounds, I'm going to erase that first 0. So if someone weighs 0 pounds, does it make sense that they burn 201.6 calories? This does not make sense. So the answer is no. If someone weighs 0 pounds, they're not going to burn 201.6 calories. And due to limited space, I didn't write that out, but you can. So I would say something like no. If someone weighed 0 pounds, it does not make sense that a person would burn 201.6 calories, because if they weigh 0 pounds, they actually do not exist. Let's take a look at the next problem. Let's take a look at the problem that's on the screen. It is from your textbook, page 179. So notice here we have a negative relationship. The explanatory variable is the central pressure, and that is in millibars, and the response variable is the wind speed, and that is in knots. Knots is similar to miles per hour. It's an abbreviation for nautical miles per hour. So we want to interpret the slope. So I'm going to scroll up here a little bit. The slope is negative 0.9748 and I'm going to put divide by, and I like to put the 1. And then the units in the y is the speed of the maximum wind speed. So I'll put max wind speed. And that's in knots. That's called nautical miles per hour. It's similar to miles per hour. Over 1, which is the pressure. And that's measured in millibars. So if you read the example, they explain the units a little bit more. So we want to interpret that. So we're going to start off with our typical phrase, on average, for every additional increase in pressure by 1 millibar, the wind speed decreases. Notice it's negative, so it decreases by 0.9748 nautical miles or knots. So this problem has a negative slope. So for every additional increase in pressure by 1 millibar, the wind speed decreases by 0.9748 knots. Let's take a look at part B. If you look at part B, does the y-intercept have a meaningful interpretation? Let's take a look at part B. Does the y-intercept have a meaningful interpretation? So that means x is 0 again. So y hat would be 1031.24 minus 0.9748 times 0, which is 1031.24. That would mean if there is no pressure, the wind speed would be 1031.24 for the hurricane. I'm not a scientist, but I think that does not have a meaningful interpretation. If there is no pressure, I would not think that the wind speed would be 1031.24 knots. You could read more information on page 179, and most of our problems will not be scientific related. They'll be similar to the rail car problem and maybe the next example that we're going to take a look at. So let's take a look at the following graph. We have my predicted, the number of miles I drove since I bought the car. So on the horizontal, you can see the age since I purchased the car, and on the vertical, the miles driven. And we want to interpret the slope. So for part A, the slope is 9765.6. Again, I'm going to put that over 1, and I'm going to write miles driven for the numerator. And for the denominator, I'm going to write age in years. And then we need to write a sentence for that. So on average, for every additional year, the car gets approximately 97. So the car's mileage increases by about 9765.6 miles. And I think I misspelled mileage. I'm going to look that up in a second. So I corrected the spelling on mileage there in blue. So in the interpretation of slope, on average, for every additional year, the car's mileage increases by about 9,765.6 miles. And then the second question was, does the y-intercept have a meaningful interpretation? So again, x is equal to 0. So if x is equal to 0, y hat will be 1199.1. So does this have a meaningful interpretation? It does. What that means is when I bought the car, it had 1,199.1 miles. So what happened there was the dealer had driven the car for about 11 or 1,200 miles before I actually purchased it. So sometimes the dealers drive the cars themselves. Other people test drive the cars. So when I bought the car had 1199.1 miles. So that would be the interpretation. So when Mr. Gazzato purchased the car, it had 1199.1 miles on it. So this does have a meaningful interpretation. So let's summarize what we learned. So down at the bottom of the page, I kind of put the template that I want you to understand. When you interpret slope, you always include the following components. On average. Second piece, for every additional, and then at that point you talk about the explanatory or the x variable. That's the denominator. So in this case, it was age in years. I'm highlighting that in blue also. And then you talk about the response variable, which is the numerator. So then you talk about the response variable. So there's 4 components when you interpret slope. Hope you found this video helpful.